Okay. Chapter 11, Section 2. Trapezoid. What's a trapezoid? Do you remember what a trapezoid is? All right. It's a quadrilateral, four-sided figure with exactly one pair of parallel sides, which are called bases. So a trapezoid is not necessarily an isosceles trapezoid. What's an isosceles trapezoid? The legs are equal or congruent to each other. A trapezoid simply is going to have two parallel bases, two sides that are parallel and the other two that are not. Let's see if we can figure out a formula for the area of a trapezoid. If we draw this diagonal, this red dashed line, we have divided it into two triangles. Are those two triangles necessarily congruent like in the parallelogram? No, they're not. They're two different triangles. So we're going to call one of them triangle 1 and the other triangle 2. How would I find the area of triangle 1? What's the formula for the area of a triangle? 1/2 base times height. 1/2, I'm going to call this base 1, the one that goes with triangle 1. 1/2 base 1 times height. And the height, right over here, they already have it marked. Now let's get the area of triangle 2. Area of triangle 2. Well, it would be 1/2 its base. I'm going to call the top side up here the base for this triangle, base 2. 1/2 base 2. Does it have the same height or a different height than the first triangle? Same height. It'd be the same height, wouldn't it? Because it's just the distance between these bases. So I can use the same letter H. So if I want the area of the complete trapezoid, what would I do with these two areas to get the total area? Add them together. Easy enough. So let's take these two and let's add them together. So I'd have 1/2 base 1 times height plus 1/2 base 2 times height. Now using your good algebra skills, do you notice anything common in those two terms that can be factored out? Anything the same? Height and 1/2. We are going to factor out 1/2 the height. And what are we left from this first term? Base 1 plus base 2. Well, guess what? That is the formula for the area of a trapezoid. So I don't know if you have been taking notes on a piece of paper of these different area formulas. I know the first ones were probably ones that you were very familiar with. Maybe you already knew the trapezoid one. I don't know. 1/2 height times base 1 plus base 2. Trapezoid area. Does it matter which one I call base 1 and which one I call base 2? No, doesn't matter at all. All right, so now we know the formula for a trapezoid, so let's try it out. Find the area of glass used to make the windshield of a van shown at right. So we essentially have a trapezoidal shape. This is a flat windshield, I guess. It's not curved like in most vehicles, so that's kind of convenient for us. So we know area is 1/2 the height times base 1 plus base 2, and the more times you write it, the more firmly it is going to be placed in your memory. What's our height? 38. Where is the height always in a trapezoid? How do I know where the height is? In the center? From base to base. It's the perpendicular distance from base to base. So whatever my bases are, which are the parallel sides, it's that perpendicular distance between them that is always the height. And base 1, doesn't matter which one we call it. 71 plus 85. Got your calculators? 72 plus 85. At least I wrote the right thing. Run it through your calculator, just as it is. 1/2 times 38, or you can call that 19, and then parentheses, 71 plus 85. What do you get? I said it again, didn't I? 72 plus 85. I don't know why I like 71 today. 2,000, what was it? 964 our unit inches square. Uh-oh, we're getting all sorts of different things. Oh. Are we getting an agreement on any number? 2983? 2,983. inches square. Yeah, I guess you shouldn't have listened to me that time. You should have done what I wrote down. Owen designed the silver earrings shown that are shaped like isosceles trapezoids. What does that isosceles mean again?
Legs are the same.
Legs are exactly the same. What is the area of each? Oh, I shouldn't have had these things left there. There was the original problem. I kind of gave a hint, didn't I? Didn't get those erased. We are going to have to know, we have our formula, we're going to have to know the height, and we're going to have to know the two bases. So what do we not know at this point? We don't know the height. Now, since it is isosceles, that's going to be important. If I drew this line right through here, that would be the height. But do I know how far that is? Only because it is isosceles, which means these things would be exactly the same here. So this middle piece is 2, leaving a total of 2 for each side, or 1 and 1. So I can use what to help me get that height? The Pythagorean theorem. So let's see if we can work it out. H squared plus, help me out, equals 3 squared. Not a special triangle, so don't try to make it a special triangle. H squared, I would have, it's not a 1, 2, 3. I'd have to subtract that 1 squared. 3 squared minus 1 squared, so the height is going to be the square root of, what's 3 squared?
9.
What's 1 squared? So square root of 8 simplified.
4 squared is 5.
Since 8 is square root of 4 times square root of 2, then it would be 2 square roots of 2. There's the height of it. So back over here. Area equals 1/2 the height, 2 square roots of 2, times base 1, how much? 4. Base 2? 2. That works. What's 1/2 of 2 square roots of 2? Square root of 2. Those would just cancel. 4 plus 2 is called 6, or it is 6 square roots of 2. What are we? Centimeters squared. There's our exact answer. 6 square roots of 2. Next shapes, rhombus and a kite, or rhombi and kites. Remember the definition of a rhombus? There's a clue on the board. What's the definition of a rhombus? It's a quadrilateral whose 4 sides are congruent. There's a rhombus. How about a kite? We have 2 pairs of congruent sides to it. So rhombus and a kite. Where are we? Rhombus or kite area formula. So again, if you've been taking some notes, here's the next one. Both a rhombus and a kite use the same formula. We won't take the time to develop this one here. 1/2 diagonal 1 times diagonal 2. You might guess how we would come up with the area formula. What shapes have we been using? The parallelogram, the trapezoid, we used what shape? Do you remember in order to figure out the shape of the whole area? Triangles. We use triangles. That's what happens right over here. When you draw the diagonals, your diagonals are going to be perpendicular to each other. And so they form nice little right triangles. And so we work on 1/2 base times height for triangles, and by the time you combine them together, this is what it simplifies to. So if you want to do it on your own, that'd be kind of cool. 1/2 diagonal 1 times diagonal 2. So let's try it out. Find the area. Area equals 1/2 diagonal 1 times diagonal 2. So 1/2, 14 times 12. Why are we using 14 and 12 instead of 7 and 6? Some things to remember about a rhombus. These diagonals not only are perpendicular, but they also bisect each other, which they even wrote up here. So 6 and 6 make a total of 12. 7 and 7 make a total of 14. Half of 14 is 7. 7 times 12, how much do you get? 84 millimeters squared. So right over here. Now on a kite, the diagonals are perpendicular. Do they bisect each other on a kite? No, they don't. So This one, 1/2 diagonal 1, diagonal 2. Half of 16 is called 8, so 8 times 9, Elisha said, is 72 inches square. Easy. You just need to remember these formulas. The math is easy generally, but remembering the formulas as we start getting a few more formulas. Find x. So here they're doing a similar thing like they did the other day. They gave us an area. So I know my formula. Forgot my 1/2, didn't I? Area is 1/2 diagonal 1 times diagonal 2. So the area is 92. 92 must equal 1/2 of what's one diagonal? 22, and the other one is x. So what's 1/2 of 22? 11. So I can find x by dividing by 11. What do you get?
8.36363.
So 8.4 if we went to the round nearest tenth. Inches square. Whoa, is that inches square? That's just inches. That one is a length, x. That diagonal is 8.4. So trying this one, what's the area formula for this shape? 1/2 h, height? I think, among that mumbling, I heard that. Area is 177. Equals 1/2, do I know the height? 13. Do I know a base?
11.
What's the other base? There you go. Now, 1/2 of 13 isn't quite so easy. It's not hard to do. But if you needed to get rid of 1/2, which you don't have to, but if you need to get rid of 1/2, what can you do? Multiply by 2. You can multiply by 2. That'd be a way of getting rid of it. I'm not going to get rid of it this time because half of 13 is really not so hard. What's half of 13? 6.5. Now we're trying to get to x. What's the next thing we should do? Divide by 6.5. Let's get rid of it. We're trying to get to the x. So divide by 6.5. I don't know, 177 divided by 6.5. 27.23. And if we're going to round our final answer to the nearest tenth, take it at least one place more. Even if you do it more than that, it's even better. So what is left? I got rid of the 6.5. All I have is 11 plus x left. So I just need to subtract 11. And what do you get? Okay, 16.23, or if we rounded to the nearest tenth at this point, 16.2 centimeters. What is the area of the kite shown right over here? Well, I know my area formula is 1/2 diagonal 1 times diagonal 2. So we don't know our diagonals. We better figure out a way to find our diagonals. Now this 6 refers to that. Sometimes it's a little hard to tell. At least I think it does. No, it doesn't. It refers to this, doesn't it?
I'm pretty sure it's black line. Black line doesn't matter. It's going to be the same thing.
Well, not going to be the same thing. That must be why this line is darker. I will agree that that is where the 6 refers to. So if that is where the 6 refers to, then I can find what? What would be the thing to look for?
Line between the blue and yellow.
Wait, those.
I want this line right over here. Can I say this whole diagonal is 12, 6 and 6? You mean this one right here?
You don't know that.
That's what we want to get. We want to figure that one out. Let's try the Pythagorean theorem. Or maybe I should ask first, is it a Pythagorean triple?
It's a special 5.
It's a 3, 4, 5. It's 8. Double the 3, we get 6. Double a 5, we get 10. Double a 4, we get 8. That thing is 8. What is this length right over here? That one is 8. Now, how am I going to, that will help me with one diagonal. One diagonal is 16. Let's get that down. That thing?
Put x plus
I don't think that green is.
I think there is a Pythagorean triple that fits this, but if we don't remember it,
15.
is it?
Yeah, 15. 18.
8 squared, I'm going to try it out. X squared, 17 squared, we've got a nice right triangle right up there. So x squared would be my 17 squared minus 8 squared. X is the square root of that, which is? There is an 8, 15, 17. So what is my other diagonal? 21. If it is 15 right over here, 15 plus that 6 gives me the other diagonal. Half of 16 is 8. 8 times 21, how much? 168 inches square. We found our area. So you probably figured out you're going to have to play around with triangles. Right triangles, trig ratios, right, Jake? Because we've learned how to do that. And other things. Here's a summary of the areas that we have learned. Parallelograms, 1/2 base times height. Base times height. Triangles, 1/2 base times height. Trapezoids, 1/2 height times base 1 plus base 2. And rhombi, 1/2 diagonal 1 times diagonal 2. In your book. Let's see if we can get some work done together. Page, what page are we? 793. Number 1. Okay, according to our shape, what formula are we going to use? Exactly. So if we are going to get our area here, we'll take 1/2 of, do we know the height? 12. Base 1? 16 plus 6. We can do this in our head. What's half of 12? 6. What's 16 and 6? 22. Well, I don't know if you can do 6 times 22 in your head. How much? I'm hearing two numbers.
132.
132, what's our unit? Feet square. Number 2. All right, our shape, what formula do we need because of this shape? There we go. So 1/2, do we know one diagonal? 18. We know both of them, 18 and 10, don't we? Oh, this one is easy for our heads. What's half of 18? 9. 9 times 10 is 90. What's our unit? Meter square. Number 3. Are we a kite again? The other one might have been a rhombus. Area is 1/2 diagonal 1 times diagonal 2. So 1/2 of, do we know them both? Oh, we do. 17 and 21. Man, this geometry stuff's easy. What do you get for this area? $178.5 meters? Meter square. Number 4. Suki is doing a fashion design at 4-H Club. Her first project is to make a simple A-line skirt. How much fabric will she need according to the design at the right? What shape? We've got a trapezoid. So we know our area formula equals, there we go. So 1/2 of, do we know the height of our skirt? Sure enough, 2.5, 2.5. 2.5. Do we know our two bases? Well, tell me one of them. 1.5 is the top. Is it 2? There's a 1.5 and a quarter, quarter and a half, 2. Sure enough, you add up that 1.5 in the middle and those 2 quarters, we get 2. I'll let you do some math. I've heard. Well, according to the book, none of the answers I have heard are correct. Is the book really wrong? Huh, the book is wrong.
What'd you get?
Tell me what you're getting. 4 point. Now, how are we getting that? And how are we getting all sorts of other different strange answers?
They're not using parentheses.
Correct. You must use these parentheses right here. Now, you can just call this times. But those parentheses means what is inside there has to be done first. In other words, what's half of 2.5? 1.25. What's 1.5 plus 2? Why don't you multiply those two together? There you go. That's what you should be getting. And I need to correct my book here. Somebody goofed when they were editing this book. Number 5. Is this one where they've given us an area and they want us to figure out the other stuff? Area equals, what's our formula on this one? There you go. And the more you say it, the more you write it, the better your memory is going to be on that formula until it's stuck right there. So they tell us the area is 78 centimeters squared. 1/2 of, do we know the height? X. What's one base?
6.4.
And the other base?
38.
Okay. So we have 78 equals 1/2 x times, why don't we add the 6.4 and the 13? How much? 19.4. You could, well, a couple of ways. You could multiply it by 2 or just multiply 1/2 times 19.4. I'm going to do that. What's half of 19.4?
That is so wrong.
9.7x, and now it's easy. Just divide by your 9.7. What do you get for x? How much? Well, good question. Tell me what you're getting. Let me see if my book is right or not. Okay, they're going to the nearest tenth. So if you were going to the nearest tenth, 8.0 centimeters. Well, that makes me feel better. The book's correct on that one. Number 6. What's our formula for this shape? There we go. So the area of this rhombus is 96. 1/2 of, what's one diagonal? 14.6. Have to double that 7.3. And what is the other diagonal? 2x. So, well, this is nice. What's half of 2? 1 times 14.6 is 14.6x. So divide by your 14.6. Nearest tenth. 6.6 inches. Number 7, we have a kite, so we know that formula. Area is 1/2 diagonal 1 times diagonal 2. And our area, 104 feet square, equals 1/2, what's one diagonal?
16.4.
16.4, and what's our other diagonal? 2x. Once again, we have one of these where we can take half of that 2. They love us until you get to the homework, right?
6.3.
6.3? 6.3 feet. Is that our last together? Oh, it is. Now you guys get to have fun. Page 793, 1 through 26. Yeah.